Hello, hi Taylor, and hi Claire as well, and welcome to this latest lecture in the A-Star series. So the next two lectures, today and tomorrow's the same time as today, we are going to focus on fractions, decimals, and percentages. So over the two classes, we're going to look at the three topics individually before looking at conversion. So probably how it will work. I'm going to start with decimals today because it follows on from the last lecture we're doing on numbers. It comes in very easy, and then focusing on the main rules to do with fractions. And then tomorrow it will probably be focusing on percentages and then conversions between as well. Just before I start as well, I'm just going to share in the chat the links to our YouTube series for this. So this lecture is being recorded, um, as they always are, and so you'll be able to watch it back later if you wish. I've shared two links in the chat. The first one is to this series, as the lectures leading up to now. It's where today's one will be put. The second link is the last entire series. So if you want to jump ahead or just see sort of a different perspective on the same topic, but the general topics don't change from one series to another. Some of these topics are quite large, so I might focus on a different area within it in one series than another. So sometimes it's good just to see additional examples or more detail on the same topic if you want to watch, or if you just want to jump ahead or look at a different topic we haven't yet covered this series, you can do it there as well. And how it will work, as always, today I'm going to share my whiteboard as we go along. Although I know there's only a couple of you here, because this gets recorded for YouTube, it will still take the form of a lecture. At the same time, if either of you've got a question at any point, please don't hesitate to ask. You can either write it in the messages, or it's no problem. In a smaller class like this, you can just pop your microphone on and ask something, whether you don't understand something or whatever it may be. It's no problem to do. All right, but as said, we are gonna first focus on sums with decimals. So we'll just start very briefly. We're going to touch on adding and subtracting with decimals. And so for both of these, we can continue to use the column method, and so it is important to make sure we line up our numbers correctly, adding zeros to them if needed. So we'll just give a couple of examples here. So yeah, so we've got e.g. we've got 3.67 plus 17.2. So you can still just use the column method for this. So you put the 3.67 above. The important thing is, but you've got the ones from the 7 and the 3 lined up, so 17.2. And while it's not necessary with addition, if you feel more comfortable, you can add zeros. You can put a 0, 3, and 17.20. A 0 at the start or a 0 at the end, it doesn't change the value. So that's just if it makes it easier to line up. And then we can just use the column method as normal. So 7 plus 0 gives us 7. 6 plus 2 gives us 8. 3 plus 7 gives us 10. So the 1 goes over, and then 1 plus the additional 1 gives us a final answer of 20 point. It gives us a final answer. So I've gone to the other window of 20.87. And welcome, Alia, as well. And So we'll move on to our next one now, and so we're going to have a look at a subtraction example here as well. So say if we've got here, if we've got 27.2 minus 1.45. Well, in this case, on a subtraction, again, you can just use the column method. In this case, it just becomes more important. We need to add a zero because we're going to have to borrow and do it like that because our number on the bottom, we've got a number in the hundredth column. Well, we need to subtract the 5 away from something, so we can add a zero there. The zero at the start is not necessary, but we can add it if we wish. So now we've done this, by adding that zero, we can just follow the normal column method, adding our decimal below. So 0 take 5, you can't do, so we need to borrow a 1. Then you do 10 take 5, which gives you 5. 1 take 4, you can't do, so you're going to borrow a 1 again from the 7. 1 in a column becomes 10 and a column to its right. So then we've got 11 take 4, which gives us 7. 6 take 1 gives us 5. 2 take 0, 2. So our final answer of 25.75. So really with adding and subtracting with decimals, as you can see, it's nothing too much additional. The only really important thing is you make sure you line it up correctly. Welcome Kutatana as well. Okay, so we're going to move on now and we're going to have a look at multiplication and division with decimals. I'll just give a sec just in case anyone needs to copy. As always, as well as any general questions, if you ever want me to go back to a previous slide at any point, please don't hesitate to ask. Okay, and so I'm just going to put up your mic off for now, Katana, because there's a bit of a noise in the background. But if you've got any questions at any point, and this applies for anyone, please don't hesitate. You can pop your mic on, or you can put it in the chat. It's no problem at all. Okay, but next, what we are going to look at is multiplication with decimals. Okay, and so to do this, the simplest way is to remove the decimal at the start and put it back in at the end. We can then use either the column or grid method in the middle, whatever you feel more comfortable with. Okay, so let's give an example of the question here. So let's say, e.g., we've got 7.65 times 8.4. And so our first stage, we've got A, we're going to remove the decimals, making a note of how many places we have moved them. Okay, so here, to remove the decimals, we want to make these integers, we want to make them whole numbers, so the decimals are coming out to the right. So we need to move this decimal, goes 2 places, it goes over the 6 and a 5. This decimal goes 1 place, so it goes over the 4, and so for a total, we've moved it 3 places. Okay, and so our part B is simply multiply the numbers using your preferred method. So I'm going to use the grid method now because I know it's the one people are sometimes less familiar with, but also the one people tend to find easier. So to use the grid method, we went through it in the last class, but you split these numbers into parts. So in effect, we've removed our decimal, so we've got 765 times 84. And so we turn this into a grid. We split the numbers into our is value column. So the 7's in the 100, the 6 in the 10s, and the 5. So we can have 760 and 5. And that's the top of our grid. And then down the side at 84, we can have 80 and we can have 4. And now all we got to do on a grid method, we can multiply our numbers and then add the zeros. So 7 eighths are 56, and then we've got 3 zeros here, so we add them. 6 eighths are 48, and then we've got 2 zeros. 5 eighths are 40, and then we've got 1 additional zero on top. Mate, be careful with that. When the sum ends in zero, you still got to add the additional zero on top of it. So 40 and then the zero on top. And then we got below, we got 7 fours of 28 plus the 2 zeros, 6 fours of 24 plus the zero, and we got 5 fours, which are 20. Now we've done that, we can just add all our numbers together. It's easiest to make sure you put everything in the correct value column to start from the biggest number and then go down to the smallest. So we've got these numbers here to 40 and 20. Double check to make sure you've included where we've got 6 numbers there, 6 numbers in the grid. Now we can just add up using the column method. So all of our zeros equal 0. We've got our 6 here for the 4 and 2. We've got 8 and 8, which gives us 16, plus 4 and 2, which gives us 22. So we've got 2 here and a 2 over. 6 and 4 is 10, plus the 2 and the 2, which gives us 14. And then we've got 5 and 1, which gives us 6. So we've got 64260. And now our stage C, put our decimal back in the same amount of spaces from right to left. So our decimal now has been removed out, and now we've just got to put it back in again. So here we've got our 64260, and we've got to move our decimal where it's moved out here, so we've got to go back in the 3 places. So 3 places, and that's going to leave us there. 0 will mean nothing now. So equals 64.26. And that's our final answer. Now just to add a little bit of a note on top. Now you can make an estimate to make sure you put the decimal in the correct place. And what I mean by that is you can round both of these numbers to one significant figure. So we've got 7.65, go round to 8. If you go to one significant figure, 8.4, again go round to 8, and say 8 times 8 equals 64. So you can see our estimate is close. It's got the decimal point in the same area, so we can be certain we've at least moved the decimal point correctly on this question. You don't have to do that, but if you've got any doubts about if your decimal point's in the right place, it's a good way to make sure. And the answer is not always going to be as close as that, but it should be exactly the same amount of digits as before the decimal place. All right, so just give a second to copy that, and then we're going to look at division with a decimal. Okay. Decimals. And so for division with decimals, we only take the decimal out of the number we are dividing by, and then your decimal will then move to the right at the end of the question. Okay, so yes, say here, if we have like 4.404 divided by 1.2. Divided by 1.2. Okay, so what we would do that first is remove the decimal, then only from the number we are dividing by, counting the spaces. To be honest, if you're given one of these questions, I'd be astonished if it wasn't just one place you're moving the decimal with division. It basically always will be, but we've got a one place here. And so now they do the division using the bus stop method. Okay, and so we got 12, so it's always a number you are divided by on the outside. So you've got 4.404. Now, the 12 times table, like you could realistically be expected to know up to sort of 11, 12 times table for the exam as like normal times tables. But if it's a times table, if it's a bigger one and you're not confident with it, you could always write out the numbers at the side to help you, like 1 times 12 is 12, and then add 12 to get to 24, and so on. In this case, we're just going to divide in. So we need to write a decimal above. 12's into 4 doesn't go. So 4 goes over. Then 3 12s are 36. 44 minus 36 gives us 8. So we've got 8 left over here. And you can write them out in whichever way, either doing it as long division, which I don't like, but you could do underneath, or you could write the sums on the side if you need to. But that's our remainder. It goes 3 times the remainder 8. So 8 goes over. Next we got 12s into 80. Well, 6 12s equals 72. Again, remainder 8. And then we got 7 12s equal 84. So again, as I said, if you needed to, you could write your 12 times table at the side to make life easier. All right, and see, finally, the decimal will move again to the right the same amount of spaces. And the reason it's going to go to the right again is because we moved it to the right to start with, we divided by a bigger number, 12, instead of 1.2, which means our answer is a smaller number. So again, by moving it one place to the right, we'll get the real answer. So we started here with 0.367, but we're going to move this decimal one place to the right. So that's going to give us a final answer of 3.67. As soon as you've got another digit here, this 0 doesn't mean anything, so we can leave it out. So it's just 3.67, and that's our final answer. All right, so I'm just going to give a minute again to copy them over, and then we are going to move on to fractions. Okay. Sorry, I'm battling here with the controls. Hopefully, third time lucky. Yeah, there we go. Fractions. So fractions are really key in maths because they come up a lot. It's important to understand what information a fraction shows. So let me show you here. If you've got a fraction, let's say we've got a fraction here. So you've got 3/4. And so the 3 is the numerator. The top number is called the numerator. And it's like how many parts we have. So here we've got 3 parts. And then we've got below, we've got this bottom number, the 4 is the denominator. And this tells us how many parts make a whole. So make a whole. So it could be make one, but in whatever it is to make a whole of it, sort of a quantity of something regardless. So it will normally be make up one whole or make a whole, however you want to say it. Okay. So with a fraction, it's important to understand that, and this means 3 things. A, if the numerator is smaller, so the top number is smaller than the denominator, so the bottom number, you always have less than 1 or less than a whole. If the numerator and denominator are the same, you always have 1. So no matter what it is, so say you could have here, you could have like 14 over 14 equals 1. But equally, if you had x squared yq over x squared yq, this just got to equal 1 because we know that the amount of parts to make up one whole, and we got the same amount of parts here. And then finally, C, and we'll come across these ones for C later. C, if the numerator, so the top number, is bigger than the denominator, and as we'll see later, this is known as an improper fraction, you always have more than 1. So you always have more than the whole. So those are the 3 things you will see there. The numerator is smaller than the denominator, always less than 1. If they are the same, you always have 1. And if the numerator is bigger than the denominator, the top number is bigger than the smaller than the bottom number, known as an improper fraction, you always have more than 1. And so I'm just going to put over here equivalent fractions and simplify it. Okay, and so if the numerator and denominator stay in proportion, you will have equivalent fractions that mean the same thing. So for example, here you could have like e.g. 1/2, we'll draw it here, equals 2/4, equals 3/6. So it's terribly drawn. See if I can get at least a little bit more central there. So I'm not the world's greatest artist, as you probably all notice. P equals 3/6 hectare. So you can see from these pictures, like all of these, no matter what it says, it's a half. It's just you can say things in different ways, but they're equivalent fractions. They mean exactly the same thing. So therefore, if the numerator and denominator of a fraction can be divided by the same amount, you can simplify it. When this is no longer possible, the fraction is in its simplest form. So let's give an example here. Normally it wouldn't be a question on its own right unless it was right at the start of the exam, but you might get a question, but often it'll be at the end of a question you have to simplify a fraction. But let's give an example down here. So we got here, write 12 over 30 in its simplest form. Well, you can, when you simplify a fraction, you can do it all in one go, or you can do it in steps. It doesn't matter which. You might be able to see the 12 and 30 both divide by 6. But if you couldn't see that, they're both even numbers. So any numbers presented 2, 4, 6, 8, or 0 are even, which means they both can divide by 2. So 12 divided by 2 equals 6. 30 divided by 2 equals 15. Well, 15 is no longer even, so does that mean it's in its simplest form? Well, no, it doesn't, because 15 is in the 3 times table, as is 6. So you could divide by 3. 6 divided by 3 equals 2. 15 divided by 3 equals 5. Both of these numbers are prime. 2 don't go into 5. So we now have it in its simplest form. And as I said, you could do this in one step as well. You could have divided 12 by 6, 30 by 6, and you'd have got that in one step. But that's not a right or a wrong way to do that. Just if you have a question like this and you can see it divides by something, do that first and then see if it is still divisible. Okay, so just give a second and again we will move on. Okay, so next we've got converting between mixed numbers and improper fractions. Okay, and so basically mixed numbers and improper fractions are two ways of showing the same information. And so first we've got mixed numbers, which is a mix of an integer or a whole number and a fraction. So for example, e.g., let's say 3 and 2/5. You've got the whole number, you've got the fraction there as well. And then B, you've got improper fractions is, as mentioned before, a fraction greater than 1 where the numerator is larger than the denominator. So the top number is larger than the bottom number. So you could have, for example, e.g. 70/5. Okay, so first of all, we're going to put here converting. So we got to convert a mixed number into mixed numbers into improper fractions. All right, so we got here to do that. We basically all you do is a multiply the whole number by the denominator, and then B, add your answer to this to the original numerator. So yeah, let's give an example here. Let's say write 5 and 2/3 as an improper fraction. Okay, so what we're going to do here, we've got our first step, we've got A, multiply the whole number by the denominator. So we got here, we got the 5, which is a whole number, times 3 equals 15. And basically what this tells us is that 5 is made up of 15/3. Because if you think about it, one whole number is made up of 3/3. So it's like 5 lots of 3/3. So the 5 is made up of 15/3. And then once we've done that, we can add it. So B, add this to our original denominator. So we can do that. We got basically the 15/3 that is made up of plus our 2/3 we had before equals 17/3. And basically of um, in terms of exam questions, you probably won't get this as a separate question, but as we're going to see later on, often you will get questions where you are given mixed numbers and you need to either add them, subtract them, multiply them, whatever it is, and you need to give your answer as a mixed number. Now, to calculate with fractions, it's much easier to convert them to improper fractions. So you probably do this at the start of the question, and then at the very end of a question, you would have to convert back. And so next we got converting mixed sorry, we're converting improper fractions to mixed fractions. And so simply divide the numerator by the denominator and put the remainder over the denominator. And so just using the same numbers here, just in the other direction, you could say e.g. 17 over 3 equals 17 divided by 3 equals 5, remainder 2 equals 5 and 2/3. So that's all you've got to do to convert back. Divide the numerator by the denominator and then put the remainder over the denominator, your main number being the integer part. All right, but we'll come to a couple of them later, or one or two of them later, of actual calculations using mixed fraction. That's when you need to practically use these skills. But understanding that relation, being able to convert between the two is very important. So I'll just switch my light on because it's getting a little bit dark in here. And we will move on then to our next skill. All right, so next what we're going to look at is adding and subtracting fractions. And so to do both of these processes, you need to have a common denominator between, so common bottom number between both fractions. Once you have this, you simply add or subtract the numerators. All right, and so to find a common denominator, it's like what we said earlier, like any fraction, as long as you keep everything in proportion, it means the same thing. So you basically, you need to create two fractions, find the denominators which are in the times table of the denominators, and once you have equivalent fractions, then making sure you keep everything in proportion and adding them together. So let's say here we got, or subtracting if that's the case. So e.g. we've got, sorry, that's not the greatest writing. We got 2/3 plus 3/5. Okay. And so the simplest way to find a common denominator is to multiply the denominators together, because 3 times 5 is logically in both the 3 and the 5 times table. And so we then need to multiply our numerators by the same as we multiply the denominators by. So here we can do 3 times 5, and 3 times 5 gives us 15. So we can add them both in, put our add, and then for our numerators, well, we multiplied 3 by 5 to get the 15. So we need to multiply 2 by 5, and that's going to give us 10, because we've done whatever we multiplied our denominator by, we need to also multiply our numerator by. And now we've got to do the same in the other direction. So we multiply 5 by 3, and so we need to multiply 3 by 3 to get to 9. Well, now we can add our two together. So we can just do 10 plus 9 equals 19, and then 15 on the bottom. So when you add, you simply add the numerators, the denominator doesn't change. Because it's more like you've got 10, 15, so it's almost like if you think about it in pizza, if you've got 3/8 of a pizza, so you've got 3 slices, you have 2 more slices at 2/8 of the pizza, where you're going to have 5/8, 5/8 slices in total, and it's the same logic here. You've got 10 15s of one thing, 9 15s of another, you've got 19 15s, you've got more than a whole now, you've got an improper fraction, but that's fine in total. And so you may get a question where one denominator is in the times table of the other, then we only need to change the smaller fraction. So let's say we've got here, e.g. 3/5 plus 1/10. Well, 2 5s are 10, so we don't need to multiply 5 and 10 together because 10 is a common multiple of 5 and 10. We can just multiply our first fraction by 2. So that becomes 3 times 2 is 6, 5 times 2 equals 10. So 6/10 plus 1/10 equals 7/10. So simple. I say it's useful to realise that, to look out for that, because it's just going to make your life a lot easier. If not, you're going to have to deal with really big numbers, and you might even, depending on the wording of the question, have to simplify in the end as well. All right, and I'm just going to show one example with subtraction, but really it's exactly the same. You're just subtracting at the end. Yeah, so you've got 7/10 minus, so you've got minus 1/4. So what we got to do here, false don't go into 10. So what we can do is you can do the 10 times 4. It's probably the easiest thing to do here. 5a is a smaller common denominator in this case, but it's still the easiest thing to do. To do 10 times 4. So we've multiplied 10 by 4, so we need to multiply 7 by 4. So 7 times 4 equals 28. Then we've got to do in the other direction. We've got 4 times 10. So we've got to do 1 times 10, which equals 10. 28 minus 10 equals 18/40. Now, nothing says we've got to simplify, but you could divide both parts by 2 if you wish to, because it is actually a common multiple of 4 and 10 is also 20. So if you had to, you could simplify by dividing by 2 and get into 9/20. All right, so that covers, addition and subtraction. As you can see, always basically let's say. Next, we are going to cover multiplication and division. Multiplication and division with fractions. And so multiplication, is the simplest skill with fractions. You simply have to multiply the numerators together and multiply the denominators together. whenever you see multiplication with fraction, think sort of that's the easy one. Not necessarily easy in that way, but think of it as the easiest one or the easiest one, and it's gonna just help sort of keep in your head. So say if you've got 3/10 times 2/3, well, we can just do 3 times 2 on the top equals 6, and then we can do 10 times 3 on the bottom equals 30. Again, if you wanted to simplify, nothing in the question says we have to. You could actually divide both of these bits by 6, so you could say 1/5. All right, and so division, um, so division with fractions, and so in order to do this, we convert division questions into multiplication questions. The way to do this is the three keywords. We write them out below. Keep, change, and flip. And just to say, it doesn't really matter which way round you have to change and flip because you can work out what it means anyway. So some students prefer to remember this, and particularly younger students, to be honest, with as KFC. I think for some it's easier to remember because it probably tastes better. But yeah, exactly. So keep, change, flip. So what that means in effect. So you've got a question here is, e.g., if we've got 2/5 divided by a quarter. So our first fraction we are going to keep, so it stays as 2/5. Now we've got a division sign and we're going to change this to a multiplication. And finally, we've got a final fraction. We've got 1/4, and we're going to flip this to 4/1. And the reason this works, it's like doing a double negative, so you end up in the same place. Well, multiplication is the opposite of division. 4/1 is the opposite of 1/4. So if we do two opposites, we end up back where we started, but just with a much easier question to do, because now we can just use the multiplication method we used before. We can multiply two numerators, which gives us 8, and multiply two denominators equals 5. And so our final answer will be an improper fraction is 8/5. And just as a general rule, it can be a little bit confusing. If you're multiplying by a normal fraction, so you're multiplying by less than 1, your final answer is always going to be bigger. So 1/5 is bigger, it's bigger than where we started. Right. And if you are dividing, sorry, I'm saying that the wrong way around. If you're multiplying by a fraction, 1/5 is smaller than where you started. If you're multiplying by a fraction which is less than 1, I apologize, I was looking at that thinking it doesn't make sense, but I was just saying the wrong word. If you multiply by a fraction that is a normal fraction, so less than 1, so you're multiplying by less than 1, your answer is always going to be smaller. So 1/5 is smaller than 3/10. To clarify that, 1/5 is smaller than 3/10. That's because if you multiply a number by 1, it stays the same. 5 times 1 equals 5. Now, if you multiply by more, it's going to grow. If you multiply by less, it's going to shrink. And with division, it's the other way around. So if you divide by less than 1, your number's going to grow, because if you divide by 1, a number stays the same. 5 divided by 1 equals 5. If you divide by more than 1, it's going to get smaller. So if you divide by less than 1, the number will get bigger. So that's why we've grown from 2/5 to 8/5, even though it's a division question. Right. Hopefully that all makes sense. Sorry, I didn't see that note before. I will pop back to the previous slide briefly. I'll just give a second here to copy, and then I will pop back to the previous slide. And can you let me know when you've got it copied over? Sorry, I obviously opened a few windows accidentally, but here you go. Um, Yeah, no problem at all. No problem at all. So we'll move on. 'Cause, yeah, we've got a couple more things I want to get through. Ideally, well, we're a little bit tight on time. Normally, I just do fractions in a class, but putting the decimals two in this first one's probably made it a little bit tight. But let's do calculation involving mixed fractions. Involving mixed fractions. And so the easiest way, I mentioned this before, but the easiest way to do this is to convert mixed fractions to improper fractions. Then, if you are asked to give your answer as a mixed fraction, you can convert back at the end. So let's give an example here. Let's say, e.g., answer below, giving your answer as a mixed fraction. So let's say we've got 2 and 2/5 times 3 and a quarter. So what we need to do first, the easy thing to do is convert to improper fractions. So we've got 2 and 2/5. We can multiply 2, our integer, by our denominator, because we've got two lots of 5/5 equals 10/5 plus the 2/5 we already got equals 12/5. Then we're going to do the same on the other side. So we've got 3 wholes. We know 4 quarters make up 1 whole, so we can do 3 times 4 equals 12 quarters. 3 wholes are made up of 12 quarters plus the other quarter we already have equals 13 quarters. All right, and so now we've done that, B now multiply for fractions, or use whatever it is at this stage. You could get a question like this where it was division or addition or subtraction, but whatever method you need to use, you do now. So we've got 12 over 5 times 13 over 4. Well, 12 times 13 equals 156. If you needed to at that stage, do a long multiplication. I wouldn't expect you to necessarily be comfortable with that. If you can do it straight off, brilliant, but if not, do a long multiplication. Then we've got 5 times 4, which gives us 20. And now we've got stage C, which is convert back to a mixed fraction. Okay, so here we've got 156. Remember, to get from a improper fraction to a mixed, we divide our numerator by our denominator. And obviously we're dealing with our 20 times table. Well, just like 2 times 7 equals 14, 20 times 7 equals 140. So we know 7, and we got remainder 14. Sorry, remainder 16. Remainder 16. And so equals 7 and 16 twentieths. And sometimes it was giving you answer in its simplest form. The question didn't say this here, but if it did, 16 and 20 divide by 4, so you could say, or 16 divided by 4 equals 4, 20 divided by 4 equals 5, or 7 and 4/5. All right, so the key, a question like that is just combining the skills we already know, but it's quite a common thing, to be honest, in the exam. You'll get given a question like that later on in the second half of the exam, and it's a little bit tougher because of the conversion of everything you've done. All right, so just give them a second more, and then we're going to do a final skill of the day. We might run over a tiny bit, but not to worry. So finally, we've got today fractions of amounts, and this is an important skill as you use similar maths many times in the exam. So it's basically, this is like the same maths in effect you use if you've got ratios and you need to divide the ratio by the whole and then split it into parts. You're basically splitting a ratio into fractions, the different fractions. Or if you've got a pie chart, you're basically splitting a pie chart into fractions. It's all the same. So to do this, to find a fraction of an amount, you A, divide by the denominator, and B, multiply your answer to A by the numerator. So let's go below. Let's say we've got 5 2/5 of 160. And just to mention in passing, because this can confuse people, this question is exactly the same as 2/5 times 160. So you could see the question written as of, you could see it as times. Times really means of. So there's just two ways of writing the same bits. So you do A 160 divided by 5, and that's going to give us 1/5 or 1 part. Because if you divide by the numerator, you're splitting it into 5 equal parts. Whereas it happens that equals 32. Again, use a long division if you need to. I wouldn't expect you to do it in your head. So 32 is 1/5 of the amount. And then B, we will need 2/5. So we can do 32 times 2, and so equals 64. And that's our final answer, 64. So if you were just finding that 1/5, you'd only have to do part A, but it's always this same sort of logic. This is really important maths to understand. Often to solve problems in a maths exam, you need to find the value of 1 part in whatever way it presents, whatever information you've got. Find the value of 1 part, and then once you've got the value of 1 part of something, you can use it to find out however many parts you need. So just very, very quickly, I'm going to show on the other side. You could be given a question where you are given a part of a total and you need to find the whole. The logic of this question is the same as you need to find 1 part in order to get to the whole. However, to achieve this, we need to do the process in the opposite direction. So A divide by the numerator, and then B multiply your answer to A by the denominator, so by the bottom number. So let's give an example here. We've got e.g. 3/5 of a total is £60. How much money is there in total? So you can do the same process, can do A, but now we've got 3/5, we want to get to 1/5, so we've got 60 divided by 3, this gives us £20, and a £20 is 1/5. We want to get to the whole, which is 5/5, so the numerator and denominator is the same, you're at the whole, so we can do our £20 times that by 5, and that's going to give us £100, which is our final answer. So you can see the logic is basically the same. We've got to find one part, but we're doing our process in the opposite direction because the question in effect are the opposite of each other. All right, I'm going to leave it there for the day. I'll just give a second so everyone can copy that, but we'll leave it there. But yeah, thank you so much to the four of you for making it along. I hope you'll have a brilliant evening. And so, as I said, tomorrow we're going to have a bit of a look at percentages, and then we'll look at conversions between fractions, decimals, and percentages. The class is at the same time tomorrow, so it will be at 7:50. I'm just going to add in the chat, by the way, for the couple of people who got in later, the playlist for this series. So this link has been, this lesson, it's been recorded. It will get uploaded by later, and you can watch the previous lectures in the series there as well. But yeah, thanks a lot to all of you, and have a brilliant night. Okay, bye bye.